All right, simplifying radicals with variables. This note sheet does have the answers listed at the end, but I will be going through the work that's required for them. Some of them are pretty straightforward based on the previous work that we've learned, and some are a little bit more challenging. So let's take a look. Question 1A. So remember, first thing is to always look at what the index is. So this is a square root because there's nothing shown. So that means we can take the root of any power that with an even exponent, and it will simplify completely. So this exponent is 12, which is an even number. And so if you think about it, remember, a to the 6 squared is a to the 12. When you're taking the square root, you're looking for one of the two equal factors. So that's a to the 6. Fast way is to divide the exponent by 2. Okay, so that's a to the 6. It doesn't state in this question to define the values of the variables, so we don't have to in this case. Really, in this case, we would, if a was negative, it would work out okay, because this would be a positive. So just be aware of that. In B, that is not an even number, so remember we need to split it up into factors where we get the biggest perfect square. So look for the next lower exponent on B that is an even number, so that's 14. So b to the 14 times b is the same as b to the 15. Square root of b to the 14 is b to the 7. And then you're left with square root of b. Okay? In this case, b would have to be positive in order to evaluate this. So we're kind of going downwards, and then we'll go to the right-hand column in a few minutes. So 75, so this has numbers and variables. So 75, so perfect square that's a factor of 75 is 25 times 3. A to the 9, be careful. So a lot of students will give me this, which is wrong. You're not taking the root of 9. That's an exponent. You can't take the root of it. You're taking the root of a to the 9. So we need to look for the next lower even number, and that's a to the 8 times a. And then you take the root of the perfect squares. They get to go out on the weekend, right? And everyone else has to stay home underneath the roof. So there's your 5. Square root of a to the 4th, a to the 8th is a to the 4th, and then you're left with square root of 3a. Okay, sometimes I try to put a little separation so that little 4 that's the exponent is not mistaken for an index. Next one, 45 is 9 times 5. A cubed, well, the next lower even is a squared times a, and b to the 4th is a perfect square. So when we do perfect square, perfect square, perfect square, and you're left with 3ab squared root 5a. Okay. Next one, we have factor of 8a out front, then square root of 50. Well, 50 is 25 times 2. A to the 5th, next lower exponent is a to the 4th times a. And so then your perfect squares. And so that's going to be 8a times 5a squared root 2a. And then 5a times 5a squared is 40a cubed root 2a. Then again, 5xy squared, that's out front. 20, same as 4 times 5, x to the 6th is 6 is an even number, so that's a perfect square. Y, we'll have to show as y squared times y. Right, nothing should change. If we simplify this, we should get back to this. So if you work backwards and forwards, it'll help you check your work. So there's perfect square, perfect square, perfect square. So that's going to be 2x to the x cubed y square root of 5y, and then simplify, right? These aren't underneath the radicals, so we can simplify those, multiply them together. 10x to the 4th y cubed root 5y. Okay, back up to the top here. Now these are cubed roots. So cubed root. So think it's got a 5 at the end. So what goes in? Does anything go into that? 5 goes into that. 27. Yeah, so 27 is a perfect cube that's a factor. I'm going to make that negative 27, so I can get rid of the negative, get it out of the radicand. Okay, and then 12 is a perfect cube because it's a multiple of 3, so I'll leave that. Then the perfect cubes get to go out on the weekend. And what are they worth when they go out? They're with negative 3, x to the 4. 12 divided by 3 is 4. And then we've got cubed root of 5 left. Okay. Next one. 128 is 64 times 2. A to the 8 is not a perfect cube. The next lower multiple of 3 is a to the 6. So that would be a to the 6 times a squared. B to the 10. 10 is not a multiple of 3. Next lower multiple of 3 is 9. So b to the 9 times b. So there's my perfect cube. There's a perfect cube. There's a perfect cube. Cubed root of 64 is 4. Cubed root of a to the 6 is a squared. Cubed root of b to the 9 is b cubed. And then cubed root of 2a squared b. All right. And remember, for cubed roots, really, if you were asked for any values for the variables, anything works, all real numbers. In I, we've got a coefficient, so 5n squared, and then cubed root. So 72 is, what goes into 72? So 2 goes into that, 36. So 8 goes into that 9 times. So that'll be negative 8. Oops. I'm just going to fix that. Negative 8 times 9 is 72. Negative 8 is a perfect cube. And then n to the 11. 11 is not a multiple of 3. The next lower is 9. So split that up into its factors. And then perfect cube, perfect cube. So 5n squared. Then negative 2n cubed times the cubed root of 9n squared. And then simplify that. Negative 10n to the 5th. Oops, gotta fix that a little bit. 10n to the 5th. Cubed root of 9n squared. Then next one here is fourth roots. So fourth root of 243. So 243 is 81 times 3. X to the 8 is a fourth power. Y to the 14th is not. 4 doesn't go into 14, so the next lower is multiple of 4 is 12. So we'll split that up into its factors. That's a fourth power, that's a fourth power, that's a fourth power. So that simplifies to 3x squared y cubed, and then the fourth root of 3y squared. Okay. Next one has a coefficient, or a monomial actually, monomial coefficient, and then fourth root. So what goes into 112? Does 16 go in? Yeah, 7 times. So that's 16 times 7. S to the 9 is not a fourth power. Next lower multiple of 4 is 8. And S times S to the 1. And then 19 is not a multiple of 4. The next lower is 16. 16 and 3. Be careful of your S's. It's hard not to make them look like 5s. I tend to do written S's when I do them, but in any case, I'll keep them the same. So that's a fourth power, that's a fourth power, that's a fourth power. So negative 5 s squared t. Fourth root of 16 is 2 s squared t to the fourth. And then fourth root of 7 st cubed. So then simplify negative 10 s to the 4 t to the fifth, fourth root of 7 st cubed. And then here, fifth root. Oops, so we've got a monomial coefficient here, so 6m cubed, fifth root. So fifth root, 3072, so it's an even number. So 8 cubed is 512. So try 3072 divided by 512, and you get 6. And look at negative 512 times 6, and then m to the 23. So this is not a multiple of 5. The next lower is 20. So we can split that up into its factors. And then this is a fifth power, and this is a fifth power. So that'll be negative 8 m to the 4, fifth root of 6m cubed. And then multiplying that through, negative 48 m to the 7, fifth root of 6m cubed. Okay, so take a look at the next page, and it says basically the opposite, going into entire radicals. So look at what the index is. It's squared, so really you are showing this as what it's worth when it goes back home on the weekend, right? They were allowed out when it's a perfect square, and now they have to go back home. So 3 squared is 9. X cubed squared is x to the 6 times 2x. So that's going to be root of 18x to the 7. Here, square root, 20 squared is 400. X to the 8 squared is x to the 16. Y squared times 3y. Simplify in there, that's going to be 1200 x to the 16 y cubed. Then, if it's square root, remember we leave the negative out. And then 14 squared is 196. P to the 6 squared is p to the 12. Cubed squared is q to the 6 times 5pq. And then simplify. And that'll be p to the 13. Oh, I got to multiply 196 by 5. Sorry about that. So that's 980 p13 q to the 7. Now, the next one here is a cubed root. So when 4x squared goes back home, goes back underneath, you have to cube it. So 4 cubed is 64. X squared cubed is x to the 6 times 3x squared, and I need that cubed root. Make sure you extend your radical so it covers everything. So that's going to be cubed root. So 64 times 3, 180, 192, x to the 8. Next one, entire radical, because it's cubed root, we can put the negative underneath. So 9 cubed is 729. Negative 9 cubed is negative 729. Y to the 4th cubed is y12 to the 12. And then multiply everything together. So multiply that by 2. It's 1,458. Y to the 13. Then cubed root. 2 cubed is 8. A cubed, b squared cubed is b to the 6 times 5a squared b. 8 times 5 is 40. A cubed times a squared is a to the 5th. B to the 6 times b is b to the 7. And then fourth roots. So 5 to the 4th is 625. T to the 4th times 2t cubed. So that's going to be 1250 t to the 7. Here, it's a negative out front. It's an even exponent, so we have to leave the negative out front. Then 6 to the 4th is 1,296. P cubed to the 4th is p to the 12 times 5p squared. $12.96 times 5 is 6,480, and that's p to the 14. And then last one, negative, but it's an odd index, so we will incorporate that back into the radicand. Negative 2 to the 5th is negative 32. M squared to the 5th is m to the 10, n to the 5th, times 4m to the 4th, n cubed. (32 times 4 is 128. M to the 14, n to the 8. Okay. And there are your answers. So that's it for simplifying.